Hello, James Flaten here from the Minnesota Space Grant with a lesson about Arduino programming, microcontroller programming. Today's Halloween, so I decided to dress up a little bit. I grew up in West Africa, so I'm wearing a West African shirt, and back then I had a little bit more hair and it was a bit more blonde. Here we go. So I'm going to allocate half my screen to slides, and on this cover slide is actually a link to where you can get these slides. I would encourage you, in fact, while watching this, perhaps to go and get the slides and see them full screen. Also posted is a list of the parts that I'm going to use. So if you want to actually try this activity, you might look at the parts list, pick up the parts, and then follow along. So this is an introduction to microcontroller programming. I'm going to use an Arduino Uno, which is just one of many microcontrollers available. And to use it, we'll talk a little bit about wiring, about sensors, and also about actuators. So this particular slide deck focuses on how to use the Arduino IDE, that stands for Integrated Development Environment, for programming this particular microcontroller, how to upload the code. Arduino calls it a sketch, so how to upload sketches to an Arduino Uno, understanding how to use a solderless breadboard so that you can build things and then attach them for the microcontroller to monitor, like sensors, or to control, like actuators. For instance, we'll make an LED blink, we'll make a servo rotate, we'll read some temperature values, we'll read some values from an inertial measurement unit. Here's a link. I won't follow this particular link, but this link goes to an even bigger slide deck, which has more sensors. I don't have those sensors with me, but if after taking a look at these activities, you want even more or some other ideas, you might follow that particular link. So first of all, what is a microcontroller? A microcontroller is, well, it's a very small computer. And so it turns out that, let me turn on the camera here. A moment. Here we go. So here's the microcontroller we're going to be using. It's called an Arduino Uno. Arduino is the company and Uno is this particular product. And so this device is not too different from what's in the middle of your laptop or your computer, except your computer has a keyboard attached. It has a computer screen attached. These are peripherals that make it user-friendly, easier for people to use. This particular microcontroller, you can attach things. We won't bother attaching keyboards and computer screens, but we will attach sensors, we will attach servos to it, and then we will program it. We will put program code onto it that it will execute. And essentially, it doesn't even have an on-off switch. As soon as you power it up, it will immediately execute whatever code is on it. So we will continue to overwrite the code. We'll put some code on it, try it out, overwrite the code, put new code on it, try that out, etc. So Arduino as a company has products including the Arduino Uno, which we'll be using, the Mega, which is bigger and faster, the Nano, which is smaller, but about the same capability as the Uno, a little bit harder to use because it is smaller. And then there are other products altogether, Teensies, BeagleBones, things like that. Today, we're going to stick with an Arduino Uno, which I think is a good place to start with microcontroller programming. It turns out Teensies, for instance, are actually programmed with the same software. And so once you know how to program an Uno, it's pretty easy to switch over to something more powerful, such as a Teensy. So here's the Uno. In fact, we can see one on the screen. Let me take this programming cable out of the way. Actually, before I do that, let me just point out that you'll need a programming cable, which plugs into your USB-A on this end and plugs into the Uno. That's a USB-B, okay? And then, of course, the microcontroller itself. You can purchase them separately, but my recommendation actually is to buy this package. Okay, so this is from Elegoo. I'm not sure how to pronounce that, elegoo.com. And it turns out they sell these two items together for less than $15 for both. And so that's the least expensive place I've found, and the products are good quality. Okay, so set that aside. We're focusing on this. If you look at the slide, you can see that there's a label diagram of the same device, but I'll just point it out on my version. So for instance, over here is a power jack. This is where you would power it with a battery. So for instance, if you were to fly it in a balloon flight, you would have perhaps a 9-volt battery and a jack, and you would power it through this port. I won't bother doing that today, but you need to know that's available. On the other hand, you would typically plug in here. So you would use your programming cable. You plug in the cable right there, and then you can program the device, and it will also get power through the cable. So that's how we're going to operate today. Across the bottom here are a series of places to plug in wires. These are called female headers, or also referred to as pins, and they're labeled. So these are the power pins, including a couple of grounds. There's a 5 volt, there's a 3.3 volt. And then these are called the analog pins. So the idea is if you're trying to read an analog voltage, a continuous voltage, you could plug into A0 through A5. So there's 6 analog pins there. On the other hand, if I look at the far side of the device, here's a whole bunch of pins. These are called the digital pins. And so there's 0 through, well, it actually goes up to pin 13. There's another ground there. And some of them have twiddles next to them. So a twiddle basically means this is a pulse width modulation pin. That's going to be important in certain applications. And we're going to be plugging in things into the digital pins a lot in these activities. Continuing, we need to understand a solderless breadboard. So let me set this aside and pull out a solderless breadboard and just point out that a solderless breadboard is a place where you can plug in wires. So the wires would typically come from, in this particular case, a jumper wire kit. So for instance, we just grab a wire, here's a wire, and you can poke it into one of these holes. So let me just push it down right there. And then you can poke it into another hole. So what I'm doing is I'm essentially connecting electrically 2 different parts of the board. You just have to understand which holes are connected automatically underneath the surface. And that's actually shown in the slide. These sets of 5, 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 these are all connected underneath the surface. And then these sets of, well, 20 or so along the edges, those are called rails, those are connected underneath the surface. So if I go forward one slide, you can see how that works. Underneath the surface of the board, I'm not going to pull off the back, but presumably you could do so, and you would see what's in the slide now. And that shows spring-loaded clips. So the idea is when I plug in here, I am now automatically connected to all 5 of these. When I plug in here, I'm automatically connected to all 5 of those. And so this would allow me to wire temporarily, this is not permanent, a component that was over here and connected electrically to a component over there on the board. Okay, we're going to be using that a lot. So let me disconnect that wire and proceed to the next slide. Let's talk a little bit about the software programming, the Arduino IDE. So what you want to do is you want to, if you haven't already done this, you want to go to this website, www.arduino.cc/en, so that's the English version, and you want to get a copy of the Arduino Integrated Development Environment, the IDE. Don't download the Windows app. The Windows app, it turns out, doesn't give you full control of the libraries the way you need to. So download the real version. I'm on a PC, and there are versions for Mac, there are versions for PC. And so we're going to write programs, sketches they call them, in a language. The language is just called Arduino, but it's essentially the same as C++, or very similar to C++. And so in this particular language, you need to have a part of your code that is run once, that's called the setup area, and then a part of your code that's run over and over again, that's called a loop area. So that will be the way programs in Arduino are organized. And my recommendation is that you put comments into your code, and the code we will look at will have comments in it. Comments can always be identified because they start with a // and then anything after the // will be ignored by the microcontroller, but will be help the users, help the people understand what the code is all about. So typically we don't run programs or write programs from scratch. We just use programs that are provided by the manufacturers of the sensors. So if you buy a temperature sensor that is controllable by an Arduino Uno, probably the manufacturer will provide the code that allows it to run, and you can find the code and just run the code and not have to write it from scratch. But you might want to tweak it. You might want to edit it a little bit. Okay, so here's what I'm going to do right now. I'm actually going to open up my Arduino and get it off to the right-hand side of the screen so I can see that at the same time as I'm watching the slide. So here it's opening up. And when it opens up with a window. And so let me just make this a little bit bigger. I'm going to put it off to the side here. I'm just resizing it a little bit. There it is. Okay. And so across the top, there is a check mark button. That's called verify. So that means check the code I've written. The code is written in this white space. Check the code I've written and make sure it could possibly run on the microcontroller that I have in mind. So you have to tell it what microcontroller you have in mind. In fact, let me do that right now. I'm going to plug in. You can watch me do this now. I'm going to plug in my Arduino. So I plug in this end of the cable to the programming port. And I'm going to take the other end of the same cable. Wow, this is going to be hard because the cable is sort of filled up. Okay, so I just plugged the Arduino, and I was hoping to have it in this orientation, and that's going to be hard just because of the way my computer is oriented. So I'll just leave it this way for now. Okay, here we go. On the Arduino IDE, in my version, I'm running version 1.8.13. I will concede this is not the most current version of the IDE, but it turns out that things have changed a little bit, and this is the one I'm comfortable with. So when you download your version, watch for it, and if it's not 1.8.13, and it probably won't be, then you might have to modify the things that I'm going to do a little tiny bit, but all of these things can be done in a pretty similar fashion. If I click on Tools, I can tell it what board I want. So for instance, there's a lot of Arduino and other kinds of boards available, and I'm using Arduino Uno, so that's good, so it knows that. And then I also have to tell it what port, and so it's pretty good at guessing, and so right now it says COM6 Arduino Uno, is that who you're talking to? And the answer is yes. So you have to check the board and the port every time, but once you know who you're talking to and what board, or sorry, what port you're going to be talking out of, then it's willing to do things like check the sketch. And so this particular sketch as written just has void and then a comment line, put setup code here. So, and then there's no actual code in it. And then it has a loop, so void setup. So that's the run one time. And then it has a loop, put most of your code here. And again, the only thing in it right now is a comment. If I were to click verify, what it will do is it will say, could this code possibly run? And the answer is there's no real code here, so it can't possibly fail. Famous last words, but I think so. It does take a little while for it to load what it needs to load so as to get ready to check things for an Arduino Uno. And then at the bottom, in the black space, it will tell you what it thinks. And right now, there's no red, so basically it thinks this is fine. In fact, it tells you this code will use 0% of the memory available to you. Okay. So across the top here, like I said, there's a verify button. There's an upload button, which actually will do the following. It will first verify that the code is appropriate, and then it will push it out through the COM port that you've chosen. And the only other one of these things I'm going to use is way over here on the right-hand side, the serial monitor. This will open up a window. If I click on that, it will open a window, and it will try to put things onto the window. And right now, it's running some code, but the actual things that this code is looking for aren't there, so it's just going to put some error messages. We'll get that window in use in a moment. Okay, so verify, upload, serial monitor. Those are in fact the only three things that I'm going to be using today. Let me close this. Continue with the bare minimum sketch. So again, sketches are organized with a setup area and a loop area. Setup is for things done once, and then once the things are ready to go, like transmit at this rate, or use this pin as an output pin, or use this pin as an input pin, then you loop. A fairly typical loop for reading a sensor value and writing it to the screen might be something like read the sensor value, calculate the answer in units that are understandable, so interpret the sensor value, and then write to the serial monitor, write to the screen, the value, and then perhaps wait for a while, like wait for 1000 milliseconds, wait for 1 full second, and then do it over again. So then go into the loop and loop over and over again, reading and writing down once a second. Let's do some activities. Here's my first activity, and that is to make an LED, a light emitting diode, on the board and also off the board on the solderless breadboard flash. Okay. So here's what I'm going to do. I'm going to skip ahead and I'm going to go and find the code. So here's the code. So let me just go and grab this code. So if I click on this link, it will open up a web browser from which I can, oops, that's not what I wanted, sorry. Shoot. Skip. Here we go. This is where it was trying to go. And let me grab the code. Just have to make this big enough that I can see the code. It's down here. So I grab right here. There's the code, goes down to there. Copy the code. Open up Arduino. And what I'm going to do is I'm going to paste this code into an Arduino sketch. So here it is. Here's an Arduino sketch ready to go. I'm going to erase what's in there, copy what I just read. And let's just look this code over for a moment. So what this code is going to do, it's called blink. So as you might imagine, it's going to turn things on and off. The first part of the code that's not comments is int LED equals 13. So that means set aside memory space for an integer, name the integer LED, the letters LED, and set in that space the number 13, at least for now and perhaps forever, okay? And then in the setup area, so here we are, the setup area. In the setup area, there's only one thing being done, and that is pin mode LED output. So apparently it's going to take this LED, this number 13, and make that particular pin an output pin. Apparently input is another option. And so it's telling it, I'm ready to talk to the world, talk to the outside world through pin number LED, pin number 13. And then here's the loop. And the loop is very simple. So the loop says digital write LED high. So in other words, activate pin 13. Make it 5 volts in this case. And then delay 1000, that's 1000 milliseconds. And then digital write LED low. In other words, turn off pin 13, make it ground. And then delay 1000, and then that's the end of the loop, so it will repeat. So in other words, turn on pin 13, wait a second, turn off pin 13, wait a second, and then repeat. Turn on, wait a second, turn off, wait a second. That's fine. Let me make sure that it knows that I'm talking to an Uno, it does, and that I'm talking on COM6, it does. And so let me first of all verify. Before it even allows me to verify, it forces me to save it. That's okay. So I'm just going to save this as blink test, and I'm just going to put it on my desktop for now. So now that it's been saved on my desktop, I can get it back easily enough, and it's checking to see if this code is at all reasonable. Hopefully it should be fine. If you were using a different microcontroller, the code might need to change, and so this code might not work on all microcontrollers, but this code was written for an Arduino. So this should be fine, and it says fine, done compiling. And now I'm going to push it, I'm going to upload it to my device. So when I upload it, it says compiling first, checking first, and now it says uploading. The device is flashing some lights, just showing that it's talking. Let's see if I can see that again. Let me do that over again. Let me close this window. And let me upload it. So watch the device. And when I'm uploading code to the device, it flashes some lights on the device showing that it's receiving new code. And now that it's done uploading, notice that there is an LED right here that is flashing. This LED is actually built in and touching pin 13 at all times. All I want to do now for my activity is I want to get this particular code to flash an LED that's built onto a breadboard. So I'm just going to set a breadboard right next to it and get that to flash as well. So here we go. Let me get this out of the way. Go back to the beginning of the activity. So the beginning of the activity says, put an LED onto your breadboard. So here I have a light emitting diode. There it is. And notice that the two legs of it are not the same length. One of them is a little bit shorter, the one closer to my finger. One is a little bit longer. The longer leg is the positive. And for a light emitting diode, it does matter. And then I have a safety resistor. This happens to be a 330 ohm safety resistor. And I'm going to put that in series with the LED just to make sure that I don't push too much current through it. So I'm going to disconnect my Arduino Uno. So right now there's no power to it. And let me just do some wiring here. So here's what I'm going to do. The first thing I'm going to do is I'm going to intentionally take one of the ground lines, there are several. There's a ground line, and bring that over and attach it to a minus rail. So in other words, now I've grounded one rail. And then I'm going to take the 5-volt line, which is right here. Okay. And I'm going to run that over to the plus rail. And I think I'll just leave these on for the entire lesson so that I have 5 volts in ground available to me on the board. Okay. Now let me take my LED. I'm going to put my LED mostly anywhere on the board. Just make sure that the 2 pins aren't in a rail so that they're shorted together, or in one column so that they're shorted together. So I'm just going to put them this way. And right now I'm putting it in so that the positive is closer to me. And now I'm going to wire. So let me just push that to the side so you can see that a little bit better. I'm going to take my safety resistor and plug that in so it's touching the negative lead, the negative leg of the LED. And I'm going to run that over and plug that also into ground. So what I've done now is I've made a partial circuit that goes from ground through a resistor, through the LED, and now I just need to power the other side of the LED. Here's one thing I could do. This is not the actual plan, but I could just power it by plugging in to the 5-volt line. And so the LED doesn't come on, and the reason is right now I don't have power on my Arduino, but if I were to power up my Arduino right now, hopefully the LED will come on. And there it does. Good. Let me bend it up so you can see it a little bit better. So the LED is on, but now it's on permanently. And the reason is I've plugged it into the 5-volt line, which is on permanently. So what I want to do instead, let me pull that out, is do what it says in the instructions, and that is attach the positive side of the LED to digital pin number 13. Usually when I'm wiring, I pull the power, but in this particular case, I'm pretty confident I can do it without shorting anything. So I'm going to plug into digital pin 13, which is right here. There we go. And now the onboard light and the offboard light are both flashing. So simple as that, how to load code and do some wiring so as to get the code to do something, in this case, make an LED flash offboard. The suggestion here is take a look at the code. In fact, I'll do that. I can go back and take a look at the code. And you'll notice that in the code, there was the turn on, wait 1,000 milliseconds, turn off, wait 1,000 milliseconds. Okay. And so it proposes, oh, that's not right. What I want to do instead is I want to open up the code that I saved. Here it is, blink test. And open up the blink code. So the proposal is, why don't you change the 1,000? Maybe make that turn on for 100 milliseconds, turn off for 100 milliseconds. Okay. Here it is. And I'm not going to do this, but I'm just pointing out that what you can do is you can edit this. You can edit this 1,000 and make it shorter or longer. You can make this shorter or longer. And in fact, if you make it short enough, eventually it'll get to the point where your eyes can't even keep up. Okay, so if you have it only on for 1 or 10 milliseconds and off for 10 milliseconds, your eyes will interpret that as continuously on. It is flashing, and if you use something like a smartphone and watch it, you can actually see that it's flashing, but your eyes won't be able to keep up. Okay, enough of that. Let me proceed to another activity. So pull the power, put away the LED, put away the resistor, put away this wire. On the other hand, I'm going to actually leave the other wires in place so that I have at all times, my board is powered and ready to go. Back to my slides. Let's talk about motors. So a motor is an example of an actuator, something that the microcontroller could tell in the environment to do. I suppose an LED in some sense is an actuator as well. And so motors, they could be DC motors that spin, they could be servo motors which rotate, they could be continuous servo motors which rotate all the way around. A standard servo only rotates through 180 degrees approximately, or they could be stepper motors. I have with me what's called a micro servo. So micro just means size and servo is the type. This is a standard servo. And so I put some arms on it and I can just see the fact that it's able to rotate, and it only rotates about 180 degrees. Okay. So this particular activity is use the microcontroller to make the servo rotate. That's fine. And so to do that, I need to plug the servo into the breadboard. And right now, this is called a female header, and this is essentially all female. So I need to add a male to male adapter. So if I plug that in here, and then I plug this in here, now I will be basically ready to start wiring the servo. Okay, continuing on to my slides though, let's look for instructions. So the instructions say, oh, rather than just telling the servo to do something, let's actually read some values from a potentiometer, interpret the values, and tell the servo to do something based on the potentiometer information. Okay, so before I go and get the code, let's actually take a look at the potentiometer. 2 slides down. So the potentiometer looks like this. Okay, if I orient it this way, then I have a dial, and I can turn the dial. Okay, and basically what's happening here is that I have a resistor in here, and by turning the dial, I'm touching the resistor at various places. So in other words, if I were to apply 5 volts at this end, ground at this end, then the middle will read the voltage partway across the resistor, which could be anywhere from 5 volts to ground. So in other words, by reading the voltage here, an analog voltage, a continuous voltage, I can tell how this thing is turned. Okay, so the proposal is put 5 volts on one end, ground on the other end. It doesn't in fact even matter. So stepping back, here's how I want to wire the servo. I want to wire the servo. Ground goes to ground. So as I look at it here, ground is on this side. So let me attach ground to ground. So here we go. Ground is the minus rail. The colors of the wires actually don't really matter. And it turns out the colors of the wires in one of these kits are based on their length. So I'm going to use all white wires because they're a reasonable length. But it might be better if I was using black for ground and red for power, things like that. Okay, yellow, sorry, orange, that's the next line over. So I've wired the ground line. Let me wire the orange line, the middle line. I want to put that to 5 volts. Okay, so here we go. Middle line here, 5 volt rail here. Good. And then the third one, the yellow line, that's the control line. So I want to wire that to D9. So digital pin 9 is right here. So let me use a slightly longer wire to make that connection. Here we go. And D9 right there. Good, so the servo is wired up. Servo is here. Okay. And then if I continue to the next slide, it reminds me how to wire the potentiometer. I'm going to put the potentiometer down here, and I want to wire the potentiometer ends. So how about this end? I'll wire that to the 5 volt rail. I haven't plugged in the potentiometer because once I do, it's hard to see the wires. The other end, I'm going to wire that one to ground rail, the negative rail. And then what it wants is it wants the middle one. So this is what's going to be in the code. And if you look at the code, you could see this happening. I want that one to be wired to A0. So here's a longer wire, green wire. Plug it into the middle right here. And go all the way over to A0. There is A0 right there. Now let me just put my potentiometer in place. So the potentiometer goes right here, plugs in. But now that the potentiometer is in place, it's a little hard to tell where those wires are touching. That's why I did it last. Okay, so now that I have the wiring done, let me step back and grab the code. So the code is going to be at this particular website. Here is the code. And I'm going to cut and paste this code into an Arduino sketch. Copy it, open Arduino. And it might open the most recent file that I was working on. It didn't, okay, but it might. And if it did, I would just start a new sketch. In this case, it gave me a fresh sketch. So the first thing I always do is I erase what's in this sketch, delete, and then I paste what I just got. And again, let's just look this over quickly. Always a good idea. So one of the first things I notice is include servo.h. This is even before the beginning of the setup function. That's called a library call. So essentially it's saying, I need additional vocabulary. And the vocabulary is defined in a library called Servo. And so go and find servo.h. If I were to go to sketch and include library, here is the list of libraries that are built in. And so there is Servo right there. We're going to use SD in a minute. Wire is here, and some other ones. And then down here, here are some libraries that I've actually added to my copy of Arduino myself down here. Okay, so more about libraries in a minute. Servo is there, that's good. And then it's going to define a servo pin is 9, a potentiometer pin is A0. That sounds like what we just wired. And then it's going to set up a potentiometer value. It's going to set up a servo object using the servo library. So there's an example of that extra vocabulary I mentioned. It's going to, in the setup, it's going to attach the servo to the servo pin. So I didn't know that vocabulary usage exactly, but now that I see it, I could say, oh, I basically understand what it's doing. It's getting ready to talk to servo pin, which is 9, as if there's a servo out there. And then here is the loop. The loop is analog read. In other words, read the voltage on the potentiometer pin, put that into the variable potentiometer value, and then do some sort of a conversion between potentiometer value and servo number. So this, I sort of know what it's up to, but I don't know the details. But then once I have the potentiometer value in the real units that I want, basically a number that goes from 0 to 1023 apparently, and then it's mapping that to 0 to 180 degrees, then I'm going to write. I'm going to write to the servo, so that's a specific write command, take the potentiometer value and force the servo to go to that specific angle. Okay, let's just make sure that it still knows that I'm an Uno, but it doesn't know what COM port. And the reason is I don't have any Uno plugged in. So I'll fix that in a moment. Push this off to the side, close this, push this off farther to the side, power up the Uno. And so notice it's flashing. That just means that it's still running that older code. And let me turn this up so that I can actually watch that arm if it were to move. I'll just hold it right here. And let me check. Ah, yes, now it remembers COM6. Ah, yes, it's remembering. And so I'm going to just try to upload it. So upload will, well, first of all, it will force me to save it. So I'm going to save it as servo test. And then it's going to confirm. So I didn't even bother doing verify as a separate step. I just said upload, and it will verify first and upload second. And watch the servo arm. As soon as the code is verified, it will start uploading it, and the lights on the Arduino Uno will flash, showing that it's getting code uploaded. So there they're flashing. And then the servo arm moved. Apparently it moved to the initial value for this particular device. And so now I'm going to grab the potentiometer and I'm going to rotate the potentiometer. And as I rotate the potentiometer, what it does is it reads the new value on the potentiometer interprets that as an angle, and then sends that angle out to the servo. So this allows the servo to be controlled, in this case, by this dial. This is just a little more exciting, as far as I'm concerned, than a piece of code that just says, try different angles without any input at all. Okay, there we have it. Controlling a servo with a potentiometer. Let me unplug this. Close that. See if there's any more slides here. Oh yeah, one more slide. So this slide just talks about the fact that a potentiometer is sort of a resistor that's laid out, and the output pin touches that resistor at various points, and you can touch different points by turning that dial. And then if you apply a voltage across the entire potentiometer from ground to VCC, in our case, we applied 5 volts, then you can measure the voltage with the output pin and interpret it as the angle on the servo. Time to take my thing apart. So I disconnected the power. I pulled the servo out, pulled the potentiometer out. I'm going to pull out these wires. I won't need them, at least not in those spots. Here was one of my control lines. Here's some power lines. I'm going to leave those two in place though, and the reason is I always want to have power and ground on my board. Let's keep going. So some comments about libraries. Generally speaking, libraries which are trying to save you time by including a bunch of code so you don't have to write it and giving you new vocabulary, but they can take up a fair amount of memory. So sometimes you might even run out of memory on the Arduino Uno if you try to have too many libraries running at the same time. Libraries typically end in .h and are included with an include statement. And if it can't find a library, it will complain. I don't know what that .h is referring to. We'll see that happen in a moment. I'm going to intentionally not include a library just to see it fail and then show you how to find the library and include it. Oh, did I go back too fast? Right. So this thing here suggests, at least for this version of the Arduino IDE, how to find the libraries. And I already did this one time. Go to Sketch and then take a look at the Include Library option, and it will list the libraries you have. And if the library you're looking for is not on the list, then I'll show you in a moment how to get it there. A couple comments about sensors. We're going to use a few different sensors now, including an analog sensor. So the two major categories of sensors are analog, where the output could be any voltage, in this case between ground and 5 volts. This is a 5-volt device. Or a digital sensor, which talks to you in on-off, on being 5 volts and off being ground. If it's a 3.3 volt device, high or on would be 3.3 volts, and ground, 0 volts, would be off. Okay, so the analog sensors, the one we're going to use, I'll put it on the screen right now. There it is. Okay, is a thermometer. Okay, and so this thermometer has 3 legs. We'll talk about how to wire them in a moment. But basically, here's something that can go wrong if you're using analog devices. They can be susceptible to noise, especially if there's voltage variations for any reason on the lines that you're trying to read. And if you use very long leads, for instance, you can sometimes lose voltage. There could be a voltage drop because of the resistance in the lead. So one small idea, at least, is keep your wiring as compact as possible when you're using analog sensors. Here's typical wiring for an analog sensor. So on the right-hand side, it shows an Arduino Uno. It's not actually organized this way, but there's a 5-volt pin, and I just plug the sensors over here. So I just power it with 5 volts, and then I have to also ground it. So I run a ground line to it, I run a 5-volt line to it, and then I monitor its output using one of the analog pins. So in this case, it looks like A2 in this nominal diagram. We'll see what makes sense for the actual code we're going to use in there. Okay, last thing is writing to a serial monitor. That's the window on the screen. And so when you open a serial monitor, one of the first things it will do is it will try to read information at the rate that the monitor, the window, is listening. And so the code will tell the Arduino what rate to send information, the baud rate, and you have to make sure the window is listening at the same rate. So this typically will be in a serial.begin statement in the code. And so serial.begin 9600 means use 9600 baud. And you just have to make sure the window is set at 9600 baud. And then to send something to that window, you will use a serial.print statement or a serial.print line. And print line statement means print the string, print the characters to the window, and then go to the next line. So you can either stay on the same line or go to the next line, depending on how you want to organize your output. Let's do an analog temperature sensor, a TMP36, okay? And so again, before grabbing the code, let's get the wiring done. Here we go. So if I take the TMP36, I notice that there it is, it's got a flat side, okay? So there's the flat side. And if I hold it this way with the flat side up, the pins are wired 1 on the left, 2 in the middle, 3 on the right. So I'm putting it with a flat side. Yeah, I can see the flat side. There we go. And so according to this diagram, I want to wire it so that pin 1, which is here, goes to the 5-volt rail. So I'll plug that into 5 volts. And then pin 3, which is on the other side, is going to go to the ground rail. The minus rail. And then pin 2 is supposed to go to analog number 2. So let me find a longer wire attached to the set of 5 that is touching the middle, and then go all the way over here to analog number 2. Here it is, 0, 1, 2. Okay, so the wiring is done. Now let's go back and get the code. Here's the code. So I'm going to grab the code. I'm going to open Arduino. Start a new sketch. Aha, it pulled up the old sketch. That's fine. So that's not the one I'm using anymore. So I'm going to say File, New. Here's a new sketch. Erase what's in there. Paste my new stuff in there. Close this old sketch. Make sure it knows that I'm talking to an Uno, and it doesn't know the port. Ah, yes, because I haven't powered it up. That's fine. I keep forgetting to do that. Close this window. It's powered up. And now it's trying to run that servo, but the servo is not attached, so nothing appears to be happening. But hopefully it will know. Yes, it does. It knows that there's now an Arduino Uno on COM6 in my case. It's not always the same COM number, interestingly enough. And let me look at the code first. So here we go. So in this particular code, I'm defining the word sensor pin as an integer to refer to A2, that's analog number 2. So by looking at the code, I can even tell what the wiring needs to be. And then in my setup, serial.begin 9600 means get ready to talk to a serial monitor at 9600 baud. And then here's the loop. The loop involves reading, in other words, set aside a variable, name it reading, and have that variable look at the value on the sensor pin, the analog value on the sensor pin. Once you've done that, calculate a new variable called voltage, and voltage will be related to reading. So in other words, if the reading is 300, that corresponds to a specific voltage. The manufacturer will tell you how to do this conversion. And then once I have the voltage, then I want to calculate a temperature in Celsius. The temperature in Celsius is related to the voltage number. And then I want to serial print the temperature in Celsius, and then print line the words, the characters, degrees C. Okay. I'm also going to generate a variable called temperature F, temperature Fahrenheit. I will calculate the temperature Fahrenheit based on the temperature Celsius, and I will serial print also temperature F, followed by the words, the characters degrees F. And then I will wait 1 second, and then I will repeat. Let's upload this sketch. Forces me to save it. So I'm just going to call this temperature test. Save. Once saved, it's now compiling, which means making the code smaller and getting rid of all the comments. And then it's going to upload the compiled code to the device. I can see it flashing, and it's done uploading, and it hasn't given me any errors. This is good. Now I'm going to open the serial monitor, because that's where it was supposed to be putting the answers. Here's the serial monitor, and nothing shows up. This is a sign that there's probably a disconnect between the rate with which it's talking and the rate with which I'm listening. And sure enough, if I look down here, I can see that it's listening at 115,200 baud, 115,200 baud, but I was actually transmitting at 9,600 baud. So let me try that instead. So now that I have 9,600 baud, now the messages are interpretable, and it comes in at 16 degrees Celsius, 61 degrees Fahrenheit. And if I take my fingers and touch thermometer, which is right now at 61 degrees Fahrenheit, 62 degrees Fahrenheit, 64 degrees Fahrenheit, 65 degrees Fahrenheit. Okay, so in other words, this particular thermometer, I'm going to even squeeze it and see if I can go up higher. So I'm above 70 now. And then if I stop touching it, then it will drift back down as it cools back off. So this thermometer is giving me temperature values in its environment, in the room, or with my fingers nearby, in real time, and it's writing them down twice. In fact, I don't really care for that writing down twice, so I'm going to make a slight code change here. Close that. The reason it wrote them down twice, oops, that was the wrong thing, sorry. Here we go. It wrote down the temperature Celsius, and then it did a serial print line. If I get rid of this LM, so I can keep everything on the same line, let me put in a few extra spaces there and upload that instead. And what you'll notice is, I think, we'll have a better output. So here we go. Serial monitor, it remembers the 9600 baud. Oh dear. Yes. Here we go, 1689 degrees Celsius, 6241 degrees Fahrenheit, all on the same line, and then it waits a second and then it redoes it. So I'm happier with this output. Okay, fine. Let me get my slides back. Close this up. The next thing we're actually going to do involves that same thermometer, so I'm not going to take the wiring away. But here's some more comments about Arduino libraries. So in general, to download a library, if you don't have it, it will complain. And so then you need to, in our case, follow a specific link, and it says download the zip. I will show this in a moment. And then it even tells you where to put it. I'm not going to do it that way. I'm going to have it automatically do it. So I'm going to give you slightly different instructions that are in the slide. It turns out that this is one of the details that's different between Arduino versions. So I'm using version 1.18.13, I believe. And if you download version 2.0.1 or what is current, you might have to fiddle a little bit to get the libraries installed, but it'll be similar to what I'm going to show you. Here, for instance, are several libraries that we will need. SD.H is already there. Wire is already there. This IMU library is not there, and I'm not going to put it there right now because I want to show you what happens when a library is missing and how to get it when we really need it. Here we go. Logging analog temperature sensor data to a micro SD card. So essentially, I'm going to use the temperature sensor, which I have there. I'm going to add an LED, which will flash when it's making its reads. And then I'm going to put the information onto an SD card. So first of all, let me disconnect the power. And let me show you the other parts that I'm going to bring in. So this is familiar. Basically, there's the LED with its safety resistor. And then this is new. I'm going to use an SD, a micro SD card breakout board. And this particular breakout board, since the Arduino does not have one built in, I'm going to wire up my own. So I'm just going to put that right over here. And I'm going to put the LED right here with the positive lead towards me, toward the SD card reader. So the positive lead is closer. And then let's wire it up. So the first thing it says is wire up the LED, sort of as expected. So here's what I'm going to do. I'm going to put the resistor, safety resistor, on and bring that over closer to the rails. Would have gone all the way to the rails, but in this case, I'll just jump across the center line because the connections don't go across the center line. And then I will go from that resistor to the negative. So in other words, what I'm doing is I'm grounding the far end of that resistor, and then that resistor is in series with the LED. Now it says run the positive lead. I guess this is the first thing it said, the positive lead for the LED to digital pin number 5. So here we go. There's the positive lead of the LED. And let me run over to digital pin number 5, which is right there. Okay, good. So the LED is wired. Thermometer is still wired. And now I need to wire the breakout board. Okay, so the breakout board has a bunch of pins on it. It actually has 7, and I'm only going to use 6. As I read them, they're upside down from my finger's perspective, but they say C0, D0, GND, SCK, VCC, DI, and CS. It turns out that there are only instructions for 6 of the 7, so I don't even need to wire anything to C0. D0 is digital out, and that needs to go to digital number 12. So let's get some wires ready to go. Here we go. D0, digital 12. Fine. Continuing on, I need GND to go to ground, so that's pretty obvious. So GND is next. Run that to the ground rail. Okay. Next up is SCK, the serial clock line, and that needs to go to D13. So here we go. D13. Good. Next, I come up to VCC, which I want to power it with 5 volts. So I'll use a orange line for going to the 5-volt rail. Anywhere along the rail is fine, so I've plugged it in way down there. And then DI. So DI needs to go to D11 on the Arduino. So here is D11. A little hard to reach. Okay. There we go. Got it in D11. And then the last one, chip select, that needs to go to D8. So here we go, chip select, CS. Bring that down here and plug it into D8. So it turns out if I look at this wiring, it's a little hard to tell what's going where. That's why it's kind of important to do these one at a time, and I'm trying to talk through them. Good. Now that I have the SD card in place, let's get the code. So here's the code. This is going to be called analog temp logger. And coincidentally, it doesn't actually show me the code when I first click on that. I have to open the code. So a .ini file is the code. And let me just find the code. Potentially, you could download the .ini file directly, but I'm going to grab the code and just cut and paste it as I have been doing. So here we go, copy. Open Arduino. And paste this code into a new Arduino sketch. Open up a new sketch. Erase what's in it. Paste the new stuff. Close up a couple windows here. So if I take a quick look, it asks for SD. In other words, this is going to be writing to an SD card reader. So I need SD vocabulary. Chip select 8. So that kind of tells you, since this is a SparkFun product, that's what they use for chip select. So that tells you a little bit about the wiring. The LED is to pin 5, digital pin 5, and the temperature is to A2. So that's familiar. Now this is important. Basically, it's going to write down the information into a file on the card, which reminds me, I haven't put an SD card. Here's a micro SD card. Let me put that into the reader. That's important. Okay, so that's in the reader now. And it's going to name the file on the card logger 00. Unless logger 00 is already on the card, in which case it's going to try logger 01 or logger 02, etc. So it's going to run up the numbers, it finds a logger XX, where XX is digits, and it finds one that isn't already in use. Okay, this will be a comma separated value file, CSV. And so we're going to use our serial monitor also at 115/200, so we're running it pretty fast. And then we have the LED pin will be output, and pin 10 is also an output. And then here's some initialization messages. So it's going to try to initialize the card. It will write this to the screen. And if it fails, it will tell us that it failed. And if it finds a card, then it will try to find a file name to use. And if it fails to find a new file name, it will say no file names available. Please clear the card before proceeding. Okay. Now, here is the string. So it's going to write temperature C first to the file and to the window. And then after that, it's only going to write numbers. It won't write temperature C every single time. So that's kind of the header of the data column if you want. Okay. It opens the file, puts that information in, and closes the file. This is typical. Keep the file open as little as possible. It may not be efficient, but it keeps you from losing data if it happens to fail while the file is open. Here's the loop. The loop is get the temperature from the sensor, and then flash the LED, turn on the LED, make it high, and then write the data first to the screen, and then also write the data to the card, and then turn off the LED, and then repeat. Okay, and then here is, once you have the temperature, interpret the temperature as some number in Celsius. Let's try it. I need to make sure that it knows that there's an Uno, and it does, and that there's an Uno, and it doesn't know that. Oh dear, I have to power it. Here we go. Okay, so now it's powered. Reopen that menu, and it says, yep, COM6 knows about it. That's good. Push the data out to COM6. And it wants me to save it, so I will. I'm going to save this as SD test. Now it's uploading the code. Takes a moment. Finished uploading. Sorry, finished compiling. Now it's uploading. Done uploading. So it should be running. And in fact, I can tell that it's running because the LED is flashing, so that I know that it's writing data down on the screen and also on the card. I can't really tell until I open the serial monitor. And notice that the serial monitor is a little confused. And the reason it's confused is because I'm listening at the wrong rate. I'm listening at 9600 baud, and it's transmitting at a much higher speed than that. I'll choose the proper speed. And now it says, initializing card failed, we're not present. Oh, that's a bad message. No, that is a bad message. I'm going to try that over again. One moment. Okay, I'm unhappy. Here's what I need to do. I need to double check my wiring. Okay, so essentially it's writing things to the screen, but apparently it's not managing to write them to the SD card. So I need to just verify that I've got my wiring right. Give me a moment. Going back to my slides. Need to take a quick look. I want, let me just unplug this. And I'm going to double check. So D0 goes to 12. That's right. Ground goes to, there's my problem. I've powered it, but my ground came out of where it had been plugged in. It wasn't grounded. I'll check them all though. SCK goes to T13. That's right. BCC goes to the power line. That's good. DI goes to digital 11. That's good. Chip select D8. That's good. Okay, so my ground had slipped out. Plug it in more firmly. Try it again. The code is already there. So since the code is already there, let me just get Arduino up. Get the serial monitor open. It turns out you can open the serial monitor without having to have the actual code on the screen. But it, in fact, does remember the most recent code. Here we go, 9600 baud. That's the wrong speed. 115200. Yes, very good. So initializing card logger08.csv. In other words, it says, I was able to find a new file name. I'm going to call it logger08. And I'm getting 16 Celsius. And if I bring in my finger, I could bring that up to 17. I can bring that up to 18, 19. And then if I take my finger away, it will drift back down from 19, back down to 18, etc. Good. So it looks like it's coming out properly on the screen. Hopefully it's coming out properly on the card. Let's find out. So I'm going to close that. I'm going to close that. And I'm going to pull the card. So first of all, I pull my power. Okay. And then I take my card out of this. And my laptop actually doesn't have a micro SD card slot. It has a full-size SD card slot. So I need to put the micro card into an adapter to make it look like a full-size card. Let me pop that into my computer and go look at logger 08. Presumably there's going to be a bunch of files here. And there they are, logger 00 up to logger 08. Not now, please. And then some other files too. This is the one I want, logger 08. Double click and it will open up this file with Excel. And there I have it. So there are the numbers, mostly 16s, and then eventually I touched it and it went up to 17, 18, 19, and then start to drift back down to 18 and 17 before I disconnected it. Good. Now I'm able to take sensor data, in this case, analog temperature sensor data, and put it onto an SD card. Let's disconnect all this stuff and do one more activity. Pull out the thermometer, pull out the LED, pull out the lines that were all attached to the breakout board, pull out the power lines, pull out that safety resistor, and I want to use the, I want to leave those two lines in place to power my board. Great. Back to square zero. Some comments about digital sensors. I've mentioned some of these already, and that is digital sensors often, always really need libraries, and it's possible that you'll run out of memory space if you try to load too many libraries at the same time, okay? In fact, truth in advertising, the next thing we're going to do requires such a large library that I can't have it resident at the same time as the SD library. So in other words, I can put the device information on the screen, but I can't put it on a card, at least not with an Arduino Uno. Typically, devices will use digital pins, although it's possible to use analog pins for digital communication sometimes. On the other hand, you can never use analog pins. You can never use digital pins for analog input. Most advanced sensors, IMU, that's what we're going to do next, GPS, other things, are digital. This is really the best way to send information quickly and efficiently, and the information will not be influenced by the length of the cables. But it turns out that if you don't have a good enough connection, you won't get the data at all. It's not like an analog where you might get the wrong data or almost right. Digital, either you get the data and it should be fine, or you don't get the data at all. Make sure you pay attention to whether the devices are 3.3 volts or 5 volts. And so the next device is a 3.3 volt device. I don't want to power it to the 5 volt rail. I might fry it. Watch out for pin conflicts. Multiple devices trying to share the same pin, but use it at the same time or possibly at a different voltage level. And if something gets hot or starts to smoke, that's usually a bad sign. Pull the power, pull your cable out of your computer right away, and look at your wiring and make sure that you haven't damaged your components or even the Arduino Uno itself. Usually the components fry first and the Uno is fine. Best not to fry anything. And then watch out for sensors that look similar. Sometimes I hand out digital temperature sensors and analog temperature sensors, and you have to read the writing on the surface of the sensor to make sure you have the right one. We're going to use an inertial measurement unit next. So here's what it looks like. Unfortunately, this particular one, which is called LSM9DS1, is out of production. And so you probably are not going to be able to buy this one. But I think it's still instructive to show you how it works. And you could do something similar to this with another inertial measurement unit. This particular measurement unit measures force, and so you can use that as a tip sensor because it can sort of notice the gravitational force, and either that's in this axis direction, or it's in this axis direction, or it's in this axis direction, etc. And it also measures rotation, so it's got 3-axis gyro, and it also gives 3-axis magnetometer. So this is called a 9-degree of freedom inertial measurement unit. Here's how to wire it up. So it only has 4 pins that need wiring. So I'm going to plug it in right there. And let's attach it as stated. So first of all, I need to ground the GND pin. So there's GND, and I will run that to ground rail. Good. And then it says attach VDD to 3.3 volt power. Ooh, careful now. I do not want to wire this one to the 5 volt rail. I need to wire this one to 3.3 volts. So here we go. There's the next pin, the VDD pin. And I have 3.3 volts available over here on my Arduino next to the 5 volts, but don't ever get the two confused. There we go. Now it's powered. Fit all the way down. Good. And then I want to attach, this is a little interesting, I'm going to attach the next 2 lines, these are called bus lines, to A4 and A5. So interestingly enough, I'm going to apply SDA to analog number 4. So I need a longer wire than that. This analog number 4 is on the far side of the Arduino. There we go. Analog number 4 goes here. And I need one more long wire. And this one is going to go to analog number 5. So here's a case where analog 4 and 5 are actually serving as a digital, what's called a bus. It's called an I2C bus. Some people call it I2C. I prefer I2C. And let's get the code. Here it is. And this code is pretty lengthy. Good thing you don't have to write this from scratch, but it's a good idea to look it over and see if you can at least understand what it's doing for you. I copy the code, I open Arduino. I'm going to put the code into a new sketch. File, new. Erase the content, delete, copy the content, power the device. Make sure that it knows who it's talking to. It knows about an Uno on COM6 and upload. And this is going to fail. Well, it's not going to fail until after I've saved it, then it's going to fail. So I'm going to call this IMU test. But the reason I know it's going to fail is because it doesn't have the IMU library yet. So it's trying to compile the sketch and it says, I don't know what you're talking about when you asked in the code to include this library. So let me just take a look. It included the wire library, the SPI library, but it didn't know what to do with the SparkFun LSM9DS1.h. So it failed there, and it told me where it failed. So here's how to get that library. I'm going to click here. This was also earlier in the slides. And so here's the library. And what I want to do is I want to click code and then download zip. And it asks me, where should I put it? Here's what it's suggesting to me, which is actually exactly what I want. I want to put it into this PC in my documents area under Arduino libraries. That's exactly where I want it. So I will just say save. Okay, I can close the browser. I can close this Arduino window. I'm not using that code anyway. And now the previous slides, I won't even go back to the previous slides, but the previous slides suggest manually finding that zip library and unpacking it, and then restarting Arduino so it finds it. It turns out that if I use the Arduino library tools, I can do the same thing automatically, and I don't have to restart Arduino. So let me go to Sketch, at least in this version of Arduino. Include library, add zip library. So now it says, where is the zip library? And I say it's in my documents area under Arduino libraries. There it is. So there's the zip library, and I just say open. And when I say open, it will install the library, and notice it suddenly isn't complaining anymore. Okay, that's good. So in other words, I didn't have to restart Arduino to get this library to be noticed. On the other hand, I still have to finish verifying it and uploading it. So I'll start over again. As soon as this is done, before I open the serial monitor window and look at the results, let's just look around the code a little bit and try to understand what it's doing. So it finished compiling. It's now uploading. Very good. Okay, so it's done. But before I look at the results, let me just point out that in this particular code, there's a lot of comments. Notice that you can put / at the beginning of a single comment line, or you can put /*, and then everything will be a comment until you do */. So lots of comments here, and then eventually */, and that means end comment. And then it included wire, included SPI, and successfully included the LSM9DS1 library. This is good. And so now it's going to use that library to set up the IMU. Notice that there's a few things here that have been commented out. This is actually fairly standard, where you put in lines of code for testing purposes, and then when you don't need to do more testing, instead of erasing the lines of code, you just comment them out. So they're available to bring back very quickly if you want to. So there's an example of something that's not being used right now, but could come back. Basically, this particular library has a gyroscope, an accelerometer, and a magnetometer. And so it's getting ready to print to them. And it's going to be printing to the screen, at least, at 115200. So remember that. And then here it's ready to send some error messages if it can't find the IMU, but it should be able to find it if I've wired it correctly and if it's working. And then in the loop section, it says, if you have gyro available. So apparently in this IMU library, you can ask it, is there information on the gyro? And if so, then you're supposed to read the gyro information right there, okay? Similarly, if you have accelerometer values available, please read them. If you have magnetometer values available, please read them. And then it says, let's print the following to the screen and to the, not to the card, to the screen only. There is no card, okay? So essentially, it's going to print gyro information, accelerometer information, and magnetometer information in 3 axes. And then it's going to, so serial print line, once you've printed all those things, give me an extra blank line. And then down here, this is a little bit more information about how it's printing the gyro information. So it prints the letter G, and then it prints the values from the IMU, calculating the gyro information for X, calculating the gyro information for Y, report it to 2 digits, and then print degrees per second. Those are the units. Okay, and then it's going to print, yes, serial print. Moment here. Okay, so serial print the gyro information, and then serial print the accelerometer information, setting it up, reading it off to 2 digits, and then writing the units. In this case, it will print it in Gs. Okay, and then down here the magnetometer units, and it will print those in Gauss. And then it can actually calculate pitch, roll, and heading using these numbers. And so it's going to calculate some things from the values that it has and print those as well. So it prints pitch and roll, and then those each to 2 digits. It's running. Let's see what the output looks like by opening the serial monitor window. And I need to make sure it's 115200. There it is. So G stands for gyro rotation values. And it claims that it's rotating slightly, and it's not rotating slightly. So that means that either it's not calibrated or it's not accurate down to the 0 degrees per second. The accelerometer values, which are really force values, are telling me that the gravitational force is basically in the positive Z direction. And then the magnetometer values are giving me information about the magnetic field in its environment, which is sitting here in my house. Here's what I want to do now. I want to take the device and I want to tip it. So watch, let me turn off auto scroll so I can tell you what to watch. Okay, so here are the accelerometer numbers. Right now it's basically 0 in the X, 0 in the Y, and about 1 in the G, in the Z direction. Okay, so watch for that number to change as I tip it. So right now it's positive 1 in the Z direction, and if I tip it on its side, notice it becomes positive 1 in the Y direction. And if I tip it on its side this way, now it becomes positive 1 in the X direction. And if I were to hold it upside down, now it's negative 1 in the Z direction. Okay, so hopefully those are understandable. This device will tell me whether I'm rotating, and so I can get the gyro numbers to do some things, the accelerometer numbers to do some things. And if I had a magnet nearby, which I don't, okay, I could get the magnetic field sensor to give me values other than this basic magnetic field, which again is related to the Earth's magnetic field, plus whatever magnetic field is in its local environment, possibly due to the electronics itself, possibly due to the furniture, possibly due to my nearby laptop. Okay, back to my slides. So we've seen a lot. That was quick. But if I continue on here, let me just point out that this has been just a very brief introduction. You can certainly look for more advanced things, and you might have to deal with advanced issues, including pin conflicts and voltage issues, hopefully not software bugs from the manufacturer, but certainly if you're doing some coding yourself, you have to watch out for bugs in what you write. Make sure that you watch the power. So especially if you're running this thing off of a battery instead of plugged into a laptop, which is necessary for a stratospheric ballooning flight, make sure that you have enough batteries that it can power it for the appropriate amount of time, possibly about 3 hours for stratospheric ballooning flight. And if you need more than one battery, put the batteries in parallel, which means you keep the same voltage, but you get longer amount of current available to you. You don't want to put the batteries in series because then the voltage adds together and you might exceed the amount of input voltage that the device can possibly deal with. Here are some resources. These aren't, in fact, the most recent ones, perhaps, but some resources where you can learn a bit more about Arduino programming. And I hope it goes well for you. Bye-bye.